took up this entire 1,0,0,0,0 size memory segment, but we don't want to do that. We need to split this memory segment up so that we can free the rest of the memory that we're not using back to the operating system. Right, so now we need to check if the current memory segment's memory length was equal to size or not. So if current memory segment memory length does not equal size, then we need to create a new free memory segment after this one for the memory allocator to use. But if it does equal size, then we can't make another memory segment after it because it's taken up all the space. Right, so now we need memory segment header, new segment header equals, now we need to calculate the position of this new segment header. So that's memory segment header pointer, 2 parentheses, uint 64 current memory segment plus size of memory segment header plus size. So this will put a new segment header directly after our old one plus the size of the requested memory. Now this is going to be a new free segment header, so new segment header free equals true. The new segment header's memory length equals cast to uint 64 current memory segment memory length, take the size of memory segment header plus size, and make sure these are both in brackets here. So we have the new segment's header's memory length equals the current memory segment's memory length casted to unsigned int 64, take the size of the new memory segment header plus the size. So that'll be the new memory length of the new header. Just put a semicolon. Now the new segment header's next free segment will be the same as the previous memory segment's next free segment. So new segment header next free segment equals current memory segment next free segment. The new segment header next segment is also equal to the current memory segment's next segment. Same with the previous segments. So new segment header previous segment now actually equals the current memory segment, and the new segment header's previous free segment equals the current memory segment's previous free segment. Now we have a new memory segment in front of our old one, so we need to change the old one's values. So current memory segment next free segment equals new segment header, and current memory segment's next segment equals new segment header. Right, now we need to make sure that our first free memory segment is actually our first free memory segment. So if current memory segment equals first free memory segment, we can now reallocate the first free memory segment to be the current memory segment's next free segment. So now next time we come through and call malloc, it'll start from this new first free memory segment, which saves us a lot of skipping through memory segments. So now we've allocated the new current memory segment, so current memory segment's free equals false, and the current memory segment's memory size is now size. Now we need to make sure that the current memory segment's previous free segment and next free segment correctly link to the new free segments on either side. So this gets a little bit complicated regarding pointers. So basically, if the current memory segment's previous free segment does not equal 0, so it's not a null pointer, we can now do current memory segment previous free segment next free segment equals the current memory segment next free segment. So yeah, it's a little bit complicated, but basically what it's doing is if it has a previous free segment, we're now making the previous free segment's next free segment skip the current memory segment and go to the next free segment, if that makes sense. And we need to do it with the next free segment to point to the previous free segment as well. So if current memory segment's next free segment does not equal 0, so if it's not a null pointer, the current memory segment's next free segment, previous free segment, equals current memory segment, previous free segment. Alright, that's all for if the size is less than the current memory length. Now we need to make sure it does the correct behavior if there is no more memory segments and we've run out of memory. So if the current memory segment, defining this if branch outside of our first one, so if the current memory segment's next free segment equals 0, so if it's a null pointer, we have run out of free memory segments and we cannot allocate this new memory. So we'll get back to this eventually, and we'll make sure that if we get to this point, we'll be able to page in some new memory. But ideally, we should never get to this point, so we should be able to predict when we need the new memory and do it before we get to this point. So, no memory remaining. So this should only happen when we've reached the physical RAM limit of our system. Right, so now, if the memory length was not big enough for the size and there is a free segment, we need to just iterate to the next free segment. So current memory segment equals current memory segment, next free segment. Right, so that should iterate through all of the current memory segments, return 1 if there's room, and if not, it will return 0. Now, outside of the while loop, we can just do return 0, and we should never get here, but I like to have that just in case. Now we just need to go up a little bit and add 2 more lines. So we need to do if current memory segment's previous segment does not equal 0, current memory segment's previous segment's next free segment equals current memory segment next free segment. And just like with next segment, we can now set it to current memory segment's next segment's previous free segment equals current memory segment's previous free segment. One more thing we need to do before we finish is actually fix a problem pointed out by Ando23 on the GitHub. Now the problem is, if there is extra space beyond this memory segment for another memory segment, it will produce it, even if there's not enough space for the memory segment header. So we need to change this not equal to a greater plus size of memory segment header. And down here we are setting it to size, but we need to make it set to size only if it has enough room to create a new segment, else it will stay the same memory length. So now we have test memory address 1. Let's make it allocate a size of 0x10. And we have test memory address 2 and test memory address 3. So each consecutive memory allocation should be a size that is 0x10 plus the size of our memory header. So in total it should be 0x40. So now that we print all of these strings, just make sure we have a gap in between them, so we do a next and a return between each one. So now each of these memory addresses should be 0x40 in front of each other. Let's find out. Alright, here we are. So the first one starts at 30, which is the size of our memory header, and then spans for 0x10, which is the memory we can actually use. And then the next one is 40 ahead, and the next one again is another 40 ahead. So it is working successfully. That's all fine and dandy for allocating memory, but what happens when we need to free memory? Well, that will be in the next video. As always, thank you for watching, and I will see you next time.